Higher homework 8, question 4. Find the stationary points on the curve. Y is equal to bracket x minus 3 and another bracket x plus 7 and determine their nature. Okay, let's have a look and see what we're going to do there. So I've got a graph of what we're going to try and achieve. So this is the curve here that we're going to be looking at. And from there what I'm interested in is finding out where the stationary points are. So the stationary points are at places where the gradient or the slope of the curve is flat. So I'm looking down here at a point, so I'm thinking that there is one of the key points that I'm looking at. So I can see there that the gradient is equal to 0 at that point, and that's what I'm going to be doing. So I'm going to work through a process with this one here, just the normal way I'm going to do it. The first way I'll be going ahead will be finding out y in a form that I can differentiate it. I'm going to differentiate, so I'll find dy by dx, and then what I'll do is I'll set dy by dx equal to 0 so that I can find this point here, and it'll be the x coordinate at this point. Once I find the x coordinate, what I'll do is I'll then find the y coordinate. So I've got the x coordinate here, I'll then find the y coordinate. From there, when I get the y coordinate, I'll then create a nature table, and from the nature table I'll be able to tell the shape of the graph, and that will justify that. Finally, I'll just make a conclusion on what I've been doing. Okay, so I'd be looking here to try and find this point here, which looks like -2 and -25. So that's really what I'm after. Okay. Right then, so let's prepare this first, and what I'll do is I'll multiply out the bracket, and I'll just use FOIL to do that. So x times x will give me x squared, that'll be plus 7x, minus 3x, and that'll give me minus 21. What I'll do is I'll just gather up the middle terms, so that should give me plus 4x, minus 21. Okay, so next step I'm going to do is I'm going to differentiate it. So dy by dx is going to be equal to, so 2 times the coefficient at the front, which is a 1, so that will be 2x, and that will be plus 4. Okay, that's that differentiated. Remember what I said we would do? We would then set the dy by dx equal to 0. So for stationary points, dy by dx equals 0. So 0 in where dy by dx is, and that equals 2x plus 4. From there what I'll do is I'll solve this by taking the 4 over to this side. That becomes a minus 4. And from there what I can see is that x is going to be equal to minus 2. So that's the first part done there. I've found the x coordinate. When I know the x coordinate, what I'll do is I'll substitute x is equal to minus 2 into the y is equal to formula. Either one of these would do, so let's use the first one that we're given. And what I'll do from there is I'll try and work out to find my y coordinate. So it's minus 2, will be substituted in here, minus 2 into here also. I'll work that through, that'll give me minus 5, and that'll be multiplied by 5, and that gives me minus 25. So what I've got is the stationary point is going to be minus 2 for my x coordinate and minus 25 for my y coordinate. Okay, so that's me found the point. So now I need to justify what the curve actually looks like, the shape of the curve, to tell whether it's a maximum or minimum, or whether it's a point of inflection. To do that, what I'll do is I'll make up a small nature table to complete that. So I only have one point, and the x value of that point was minus 2. So I'll start with a minus 2 somewhere in the middle there. What I'll be interested in is a point that's going to be coming along from the left hand side of the curve on the x-axis, and I'm interested in the point minus 3. That's the one just next to it. And I'm interested in the point that's just going away from this, minus 2. So I could choose -1, but an easy one to work through would be if I just take the value of x equals 1. In the nature table, it's really important that we use dy by dx in here to work out the gradient. I already know that the gradient here is going to be equal to 0 because that's what I set it at over here. So dy by dx equals 0, that's also the gradient. Also the gradient there is equal to 0. Okay, so what I'll do here is I'll substitute -3 into this equation here, the dy by dx equation, which is 2x plus 4. So to work this through, I'll go for 2 times -3 plus 4, so that will give me -6 plus 4 gives me -2. And the key thing I'm looking for there is it a positive or a negative value? That there is a negative value. I'll do the same with the point 1 and substitute it in here. So I've got 2 times 1 plus 4, that gives me 2 plus 4 gives me 6. That's a positive value there. So there's my positive value. What I'm then interested in doing is to just make sure that I find the shape of the graph from the nature table. So shape is going to be negative gradient, so that's going to run from here down to here. I know it's flat when it gets to the stationary point, and then it's going to go back up the way with a positive gradient after -2. So that's the shape of my graph. The graph turns at the bottom. So if it turns at the bottom, it turns at its minimum turning point. So it's a minimum turning point, and I'm just going to write the coordinates here again. And that's -2, -25. Okay, just put a wee @ sign there. Okay, then my conclusion will be, I'm just going to say that the curve has a minimum turning point at, and I'll just make sure I get my coordinates correct here, -2, -25, and that's the question completed. Right, let's see where the marks are going to be given here. I'll give 1 mark for preparing for differentiation to start with, another mark for working out dy by dx. I'm going to look for 1 mark for setting up the stationary points equal to 0, and I also want to see this 0 kind of being in there as well as part of that mark. Next I'll be looking for my x value, so an x value of -2. I'll then look for the y value, so the y value was worked out here, which is equal to -25. I'm looking then for the nature table to be set up correctly and evaluated out correctly, and with specific reference to having dy by dx into this point here, so that's critical. And finally, for making a statement that's correct according to what I've found in my nature table. Okay, so let's see how many points we've got for this one. So 1, 2, 3, 4, 5, 6, 7. I've got 7 marks. Okay, that's that.